All right, today we are diving into a really powerful programming technique called prefix sums. Seriously, this is one of those clever tricks that can take a slow, clunky calculation and make it feel like magic. By the end of this, you're going to see exactly how it's done.
So, let me just throw this challenge at you. You've got this massive list of numbers, and people are going to ask you over and over again for the sum of different chunks of that list. We're talking thousands, maybe millions of questions. How on earth do you do that without your program just grinding to a halt? Well, that's the exact problem we're going to solve today.
You know, at the heart of this whole thing, there are really two ways to go. You've got the obvious way, right? The slow way. Every time someone asks for a sum, you just loop through the numbers and add them up. It's simple, but man, is it slow. Then there's the optimized way, the fast way. It's a clever method where you do a little bit of work up front, and then bam, you can get any answer you need instantly.
So, let's start by digging into that slow method. We'll call it the repetitive sum problem. Because once you really feel the pain of how inefficient this simple looping is, you'll truly appreciate just how elegant the faster solution is.
Okay, to make this super clear and concrete, we're going to use this one simple little array for pretty much our whole explanation. 10, 20, 10, 5, and 15. Just kind of burn that list into your memory for the next few minutes.
So if I asked you for the sum from the second element to the fourth, that's index 1 to 3, the naive or brute force way is just to loop. You'd grab the 20, add the 10, then add the 5, and you'd get 35. And look, for one question, that's totally fine. But what happens when I ask you 1,000 more questions just like it? You're doing all that looping and adding again and again and again. It is just incredibly wasteful.
So, how do we escape that slow, repetitive loop? Well, this brings us to a really clever trick. It's all about doing a little bit of work up front, a step we call pre-processing that's going to completely change the game.
The solution, the hero of our story, is something called a prefix sum array. It's basically a helper array that we create, and all it does is store the running total of our original array. Every spot in this new array tells you the cumulative sum of all the numbers up to that point.
Let's actually build one together, using our example. We start with the first number from the original array, which is 10. Simple enough. Now for the second spot, we take our current running total, 10, and add the next number, 20, to get 30. And we just keep this pattern going. Take our new total, 30, add the next number, 10, to get 40. Then 40 plus 5 is 45, and finally, 45 plus 15 gives us 60. And there you have it. That's our finished prefix sum array.
Now, building this array means we have to go through our original list just one time. In Big O notation, we call that an O of N operation. The best way to think about it is like an upfront investment. Yeah, we're doing a little bit of work once, but we are about to reap the rewards of insane speed over and over again. Okay, we've made our investment. We did the pre-processing. Now let's see the payoff. This is where we get those instant answers we were promised. And believe it or not, it all comes down to one simple subtraction.
Right, so we've got this new array now. 10, 30, 40, 45, 60. It's a neat little list of running totals, sure, but how does this actually help us find the sum of a specific slice, like from index 1 to 3?
And here it is. This is the secret sauce, the golden formula. To get the sum of any range, from sum left index L to right index R, you just take the value from our prefix array at position R, and you subtract the value at position L minus 1. That's it. One single subtraction. No loops, just an answer.
Let's put this formula to the test. Remember our original question, the sum from index 1 to 3. Well, we take prefix 3, which is 45, and subtract prefix 0, which is 10. And what do we get? 35. That's the exact same answer we got from looping, but now it was just one operation. Let's try another one. The sum from index 2 to 4. That's going to be prefix 4 minus prefix 1, or 60 minus 30, boom, 30. It is just unbelievably fast.
Now hold on, there is one super crucial detail here, a little trap you have to watch out for. What happens if your range starts at the very beginning, at index 0? The formula, prefix L-1, would try to look at index -1, and your program will crash. So you have to handle this edge case. For any range that starts at index 0, the answer is simply the value at prefix R. No subtraction needed.
And this chart really just says it all. The naive loopy approach, that tall bar, takes a long time for every single question. But the prefix sum approach? After that one-time setup cost, every single query is O of 1. Constant time. Instant. When you're dealing with thousands of queries, the difference isn't just big, it's astronomical.
But here's where it gets even cooler. This whole idea of pre-processing a running total isn't just for numbers. We can use the exact same logic to solve problems with strings too.
So instead of a running sum of numbers, we can keep a running count of characters. Just imagine, for every single spot in a string, we pre-calculate how many A's we've seen so far, how many B's, how many C's, and so on. And once you have that data pre-calculated, the logic is identical. You want to know how many A's are in some substring? You just take the total count of A's up to the end of your range and subtract the total count up to the spot right before it. Once again, you get an instant answer.
Okay, so you get the concept now. It's powerful. Let's move on to actually mastering this thing in practice. And that means knowing the common mistakes to avoid and, how to talk about this solution like a pro.
Let's go over the common pitfalls, because these will save you some real headaches. First and foremost, the classic off by 1 error. It is so easy to forget that the formula is prefix R minus prefix L minus 1. Second, you absolutely cannot forget to handle that L equals 0 edge case we talked about. Third, watch out for integer overflow. If your numbers are huge, the sums can get even bigger, so make sure you're using a data type that can handle it, like a long. And finally, a question I get a lot, does this work with negative numbers? Yes, absolutely. It works perfectly.
And if you find yourself in a technical interview, this stuff is pure gold. When you get a problem that involves a ton of sum queries on an array that doesn't change, be the person who suggests prefix sums. Make sure you explain the trade-off, that O of n upfront cost for the O of 1 query time. And definitely mention the L equals 0 edge case. That shows real attention to detail. For bonus points, you can even connect it to more complex problems, noting how it's a building block when you pair it with things like hash maps.
So if you remember just one thing from all of this, let it be this. Sometimes the smartest solution is to invest a little bit of time up front to pre-process your data. That initial work can turn what seems like a slow, repetitive nightmare into a series of beautiful, instant operations.
And that leaves us with one final question to chew on. We've seen the power of a running total, but what other kinds of running data could you pre-calculate? What about a running minimum, or a running maximum, or a running product? What totally new kinds of questions could you answer instantly if you prepared that data ahead of time? Something to think about. Thanks so much for tuning in.